Because everybody knows you take a day off the day before prom. That's so crazy. I'm glad they scheduled a game. Ha ha ha. No, you need to be here. You missed it. All right, here we go. All right. So what we're going to be doing, folks, is we're going to be using real numbers. Right triangles. The all-star trick. No, that's wrong. I know. All-star trig class, etc., and other stuff to solve for exact values using the addition and subtraction. Yes? A terminates in quadrant 1 and B terminates in quadrant 3. Find the following. Exact values that way we don't have to listen. If sine of A is equal to 5 over 13, tangent of B is equal to 3 over 4, where A terminates in quadrant 1 and B terminates in quadrant 3, find the following exact values of the given. Of the following examples is what it should say. Because we are going to use this information to do our 3 examples. Let me move that up. Is that a little better? Yeah. Okay. Now, this information provides us with what we have to do before we get to those formulas, because we're going to revisit those addition and subtraction formulas, okay? Now, it says we have sine A and tangent of B. So, folks, what that means is we're going to have 2 triangles, 2 right triangles. And I'm just drawing random right triangles. I'm going to draw one with A in the bottom corner, and the second triangle will have a B in its bottom corner. These are just random right triangles. Why am I using right triangles? Say it again. Sine, cosine, and tangent. I've got those sine values and the tangent values. Okay. So, where is where is triangle A? Go back. Quadrant 1. What do we have to know about quadrant 1? Why is that important? Positive, 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 right? Everything is positive. Cosine, sine, and tangent are all positive in quadrant 1. We're also told in the problem that B, angle B, terminates in the 3rd quadrant. What are the signs in the 3rd quadrant? Negative, negative, positive. So that means cosine, sine, and tangent. Right on? Okay. Go back. Okay. Yes? That is exactly right. There can only be one positive. There will always be 2 negatives and 1 positive. Okay? And if you need to remember that, Go back to this right here, all-star trig class, which means only sine is positive in the second quadrant, only tangent's positive in the third, only cosine's positive in the fourth. What's positive in the first? All are positive in the first, okay? So just go back, remember on that. Now, what are we given in triangle A? We're given that the sine of A is 5 over 13. Folks, just like Tyler thinks Sokotoa, he thinks that, I think some old horse. Some of you think some old hippie. Some old horse. I'm not sure. Some old hippie. So where am I going to put the 5 and the 13? Opposite over hypotenuse. And I'm going to go ahead and I'm going to put in the information just so I don't have to keep going up and down, up and down. Quadrant 3, tangent of B is 3 over 4. Some old horse caught a horse, taking oats away. Oats away, 3 over 4 is the opposite and the adjacent. What was the number? Dang it. 3/4. Opposite and adjacent. Now, okay, now, what are we missing? We're missing our two, we've got a side in each of the triangles that we're missing. How do we find it? Say what? Pythagorean theorem. Now look at those sides though. What did you say? Some of you think ABC thing. I think hypotenuse squared is equal to leg squared plus leg squared. It's the Pythagorean theorem. However, look at those values. 5, boom, 13. Certain triangles. So what's the missing side? What is it? 5, 12, 13. Very good. What are they called? Pythagorean what? Triples. We're going to write that down, okay? Pythagorean triples, folks. What's this other triangle? 3, 4. There you go. That a class. Pythagorean triples, you've got to remember the number one, most common one that occurs is 3, 4, 5 or any multiple of that one. The second one that shows up a lot is the 5, 12, 13. So much so I don't remember the others, but there are several others. Now, if I don't have a triple, then what do I have to use? Please write that down. If I don't have a Pythagorean triple, then use the Pythagorean equation. Hypotenuse squared equals leg squared plus leg squared. Some of you use the ABC thing. You write that down if that's what you use. All the problems won't take this long. Promise. Okay? Now, we've got our triangle set up. You know we're going to do the work with the addition and subtraction formulas. So what we've got to do is I want to list my sine, cosine, and tangent of both of these triangles. This is old stuff. This isn't new stuff. So here we go. Sine of A is equal to what? Opposite over who? 5 over 13. Cosine of A. Some old horse called a horse. 12 over 13. And the tangent is, some old horse called a horse taking oats away. 5 over 12. Hey, what do you have to go back and check? You better check your signs. Are my signs correct on this triangle, sine, cosine, and tangent values? Why, Damien? They're all positive. Why? Because it's in the first quadrant. Okay? Now, go to the second triangle. Let's do the same thing. All right? Sine of B is what, y'all? Some old horse. Opposite over hypotenuse is 3 over 5. Cosine of B. Hold that thought. Hold that thought. What's the cosine value? 4 over 5. Adjacent over hypotenuse. And the tangent, opposite over adjacent is 3 over 4. Now, Tyler, say it again. Why? Because you got to go back. This is when I put my signs in. I like to go on and tear up my triangle, throw my values in, and then at the end, go back and take care of your signs, your SIGN signs. So, just like he said, sine and cosine will be negative, tangent will be positive. Why? Because this triangle ends up being in the third quadrant. All right, we got all that work done, right? Now we're ready to do this for real. We have not even started. We have started the prep work. Now we got the problem. This is the easy part. That's easy. It's just time consuming, isn't it? That's easy. That's not a big deal at all. You ready for this? Yeah. Yes. Go ahead. I need that. Seriously, I'm not lying. What if y'all all started stomping your feet? Don't do it. Like you're in the bleachers. Don't do it. They would think something was wrong. No, let's don't. Herd of elephants. We could. Y'all are evil. I'm just saying. I'm glad I don't teach y'all all day long. We would get into some trouble. Yes, sir. Oh, this is so easy. Oh, my goodness, this is easy. No. I said the prep work is just time consuming. It's very easy. It's just time consuming. Hey, what is sine of A plus B? Hey, where do you go? Card. Let's write it down. What's the formula? Sine A, cosine B plus cosine A, sine B. Seriously, this is all straight off the card. All right, now you've got your picture right there above. Mine's on the other page, right? Folks, what was the sine value of A? What? Okay. Times. I'll put a dot there. Here, I'll take care of it for you. Okay, good. What's cosine value of angle B? Negative 4 over 5. Plus cosine of A. Times, what's the sine of B? Negative 3/5. Oh, this is so difficult. Ooh, multiplying and adding fractions. Why? Calculator. Now, let me tell you something. Keep the denominators the same because we're multiplying straight across here. 5 times, I would assume, and we did in first block, that you would cross cancel out the 5s. But if you do that, then we're going to lose our like denominators, okay? So I want to keep negative 20 over 65 because I don't have anything over here that will cancel out. 12 times negative 3 is negative 36. 13 times 5 is 65. Hello. What's negative 20 plus negative 36? I can do this on paper in my head faster than you can put it in your calculator. Don't be a sack of, okay? Do the work. What's that mean? What have we just found? We found the sine value for angles A plus B using the sine addition formula. When you get your answer, if it can be reduced, then yes. What happens if you solve and get a radical? Leave it in simplest radical form. Fix it. If you had an answer that had, or a side that was square root of 8, what would you do to that? How do you simplify that? 4 times 2, what's the square root of 4? Where's it go? Leave your answer as 2 root 2. Hey, I'm going to find out your algebra skills here, okay? Because it's really more algebra than anything. If the radical's in the bottom, what do you have to do? Rationalize. Multiply by the conjugate. I know you love this. Here we go. Any questions on that first one?
Yeah. What do you mean? Like, put it in the square root, like it's in the simplest form?
Yes, simplest radical form. If it happens to come out with a radical. All right, let's look at another one. Same information, same 2 triangles, A and B. Y'all's imagination. Folks, I'm going to give you this, okay? It's going to say, find the cosine of A minus B. Where do you go? Card, okay? It will say, here's your information, find the cosine of A minus B. Well, our given information was the stuff we did on the first page with the 2 triangles. What's the formula? Hey, do that one for me. You don't need me to guide you through it. You were using the same information. All right. What's my cosine of A value? Cosine of B. All right, Damien. Sine of A? Negative 3 over 5. Okay. Just simplify. Did y'all get negative 63 over 65? Oh, this is so difficult, isn't it? Does this make you want to pull your hair out? Bless you. Here, hey, how many of you got this? Hold on. Hold on, let me look. Hold on. Let me look. Go. High five in the air. Yes. Out of class. Last one. Questions at all? Yes. Each. For your homework, you've got 6 problems, and you're going to have a set of triangles for each 2. For the first 2, you have a set of triangles. For the second 2, you have a set of triangles. For the last 2, you have another set of triangles. 3 times for your homework. You're going to get it in like 5 minutes. Fair enough? Okay, you all right? Don't cry. Here we go. What? Just 6 problems. That's it. This, we're done after this one. Is that all right? You sure? I can make... Okay. No, we're good. All right, we got tangent of A minus B. Now, this is the one that's going to give you the biggest fit. Just because this is where you're going to have to, or I'm going to go old school. Y'all can do your little fractions within a fraction. I'm not doing that. Go straight to your card. Tangent of A, I think it's minus tangent of B over 1 plus tangent A, tangent B. Is that right? Now, old school. Old school is awesome. What I've done is I've just gone old school and I've got the numerator divided by the denominator. Yes, sir. Very good. You want to do this one together, or you want to struggle through this one? Go on, struggle. I don't want to help. A mistake. I made a mistake. I claim it. It's the only one I'll make all day. So let's check this out. Folks, when you have addition or subtraction of fractions, unless you're using your calculator, which you don't need, and by the way, you can't use on Monday, remember you got to have like denominators. 4 goes into 12 3 times. 3 times 3 is 9. 1 plus, follow order of operations, 5/12 times 3/4 is 15/48, and I'm not reducing here. It doesn't matter one way or the other, whether you do or don't. Yeah, it's fine if you did. 5 minus 9 is negative 4/12, which of course will reduce eventually. 48 over 48, is that right? I'm not reducing here. I'm going to reduce it to end. You guys with me? Okay. 48 plus 15 is 63. And now, copy, change, flip, multiply by the reciprocal, and now's when I reduce. I have no idea. 12 goes into 12 one time, 12 goes into 48 4 times, and that's going to give me negative 16 over 63. How many of you had that as your value? Look at you. Excellent. How many of you reduced at the beginning? You waited to the end? Yeah, it doesn't really matter which way you do it. We're going to get the same answer in the end, okay? Any questions at all? How you feel about this? What's the most difficult part? The prep work. And it's not really difficult. It's just time consuming. You really have to be sure you be careful about what? The signs. You better be mindful. I'm sorry. Oh, God, Kaylee. No, just kidding. Kaylee, stop hitting me. No, it's recorded. She didn't hit me. She did not hit me. Be mindful of your signs, folks, depending upon which quadrant the triangles fall. Okay? So here's what you're going to do. I'm going to hand you a worksheet in a moment, and you're going to do the following problems. 35 through 40. Okay? Yeah, in a minute. 35 through 40. The first two will be, I think, the cosine formulas. The second two will be the sine formulas, and the last two will be the tangent formulas. You're going to have to do 3 sets of triangles. One set for 35 and 36, a second set for 37 and 38, and then your last set for 39 and 40. Okay? Let me get